All right, welcome back. We'll start with part 2. So for part 1, if you want to do example, you can refer to practice 33.1. Okay, it's a simple example. You can really try it yourselves. All right, in this part, we'll talk about how to make soap and the reaction, also the steps to make soap in the lab. So first thing, soaps. There's a reaction name for it. It's called saponification. So please highlight this now. And it involves fat or oils with strong alkali. All right, heating this too with strong alkali. Either we use NaOH or KOH. And this is saponification, forming soap. Over here, you can see the picture at the bottom. You can make this in labs. So in the past, that's how they make soap. So why they make it different? Because they add different ingredients or stuff to look different. But the main ingredients you need this to make soap. So if we have enough time, if we're on schedule, we can try to make soap in the lab. All right, do you have to know this? Yes, so put a star over here. How do you make soap? Now, it's been asked in Cs only. It has not been asked in DSE. So again, you have to keep your heads up over here. But very, very unlikely though. This one is useful for lab. So what you need is oil. So this time they're using castor oil because it's easily obtainable. And concentrated sodium hydroxide. Heat is a must over here. Okay, heat is a must. You need heat for the reaction to begin. Now they add sodium chloride over here. The reason why they add sodium chloride over here is to lower the solubility of the soap in water. So you decrease the solubility of the soap, so it starts to float. So please highlight this part, please. Okay. The reason why we add con NaCl. Highlight these two lines. So now we have soap. Now how do we obtain soap? Now these are two different distinct layers. So I can just distill it out or filtrate it out actually. We filtrate it out and then now we distill it afterwards with adding distilled water and allow it to dry, and that's how you get soap. Really simple. So this is how you obtain soap. So that means this is soapy detergent right here. So in order to make the soapless detergent, which is from petroleum, if you remember, you cannot make it in the lab, obviously, because of the restrictions and the apparatus. So let's have a look at this one. The main difference between soapless and soap is here. In soapy detergent, we add strong alkali at the very beginning, and the reactant is oil or fatty acid. Over here, it's a petroleum, hydrocarbon, and you add concentrated sulfuric acid. Now this step is called sulfonation. Do you have to know this? Yes. And then now this is very acidic. All right, this is still not soap. Remember, soap, all right, soap is actually a salt. All right, in this case, for this one. So you add NaOH to neutralize it, and this is the soapless detergent. So how do we know it's soapless or soapy? We look at the anionic hydrophilic head. So if it's SO3 negative, anything will sulfonate or sulfate, that is soapless. If it's with COO negative, which means carboxyl, that is soapy. Okay, make sure you are able to identify these two. That's the basic thing you have to know. Now, more complicated as in how exactly this process, which means forming soap, is happening in terms of chemical reaction or chemical formulas. So before we do that, we have to understand the structures of fat and oils. Okay, so for biology students, I'm pretty sure you have gone through this in bio lesson already, but for physics students, please pay attention. To form fats or oil, okay, we will need this is called formation of fat or oil, okay? Fats, basically. We need two things. Number one, we need alcohol. You can see it's an alcohol group. And here, it's a acid group. So carboxyl group as well as a hydroxyl group. So what happens is that they combine to form, what's this called? Yes, ester. So fat is basically an ester. Right? Fats are basically an ester. So you will normally there's a name for these. There are three groups, OH groups. We call it glycerol, And we have 3CH. Now this is R. It can be as long as possible. R means as long as possible, but the main group is carboxyl group. So when they combine, they become triester. There's a common name for that. We call it triglyceride. Do you have to know this? At least you know this is a triester. That's good enough. That means it's acid plus alcohol is equal to ester. It's just they're three connected in a row. All right, so you can see it's been asked in DSC 2014. All right, now the reaction. So now you know what is fat. So how is the reaction going? So at the bottom of the book, put a star in this one. Important is that, do you have to memorize how to write this? No, they will never ask you to write. Instead, they will give you an equation and ask you to predict the product. So this one is an acid, fatty acid, or triglyceride, sorry. Okay, so COOH. How do we know this? It's because thanks to this ester group. And then if you remember, to form soapy detergent, we need fat plus sodium hydroxide, concentrated, or potassium hydroxide. So this, we have the fat and we have the sodium hydroxide. Now you'll notice we need 3. Why? Because we are breaking down now. So this is called hydrolysis, all right, if you remember in the previous chapter. We're just breaking down, and then when these two break down, the alcohol will become normal. Now since we're adding sodium hydroxide, okay, we will get salt. If it's sodium hydroxide, we get salt. If it's acid, we get acid. Okay, let me repeat this concept. I think I've not mentioned this in the previous chapter, so please pay attention. So, if I have an ester, so for example, C-double-O, O, and then C. I have ester over here. Now this is already in textbook in the unit 32, but I'll repeat over here again. So if I have, what you have learned today as well that I've mentioned was, when I want to break this, okay, I want to break this, I just have to add an acid and water, okay, hydrolysis. So what happens, I split these two, so I have COH, and then plus OH, CH3. So I'll have alcohol coming from the alcohol side, and then I have the acid coming from the acid side. Now, what if I don't use acid? What if I am using alkali? Now for alkali, everything will be the same for alcohol. But for acid, since we're using alkali, so the acid will actually not be formed because it's reacting with the alkali. So instead, it will form a salt. Okay, so depending on the cation over here, we can just add it over here. But since we don't know, we just become COO negative. So that's the major difference. If I add acid, I can get a complete acidic acid, carboxylic acid. But if I add alkali, I will not get a acid. I will get the salt, but I will still get the alcohol. So put a star over here, make a notes. All right. So let's go back over here. So if you understand that concept, this will be a lot easier to understand. So since this is an ester group, we break it down, but since this is alkali, what happens is I get salt. And this salt is basically soap. And this is the property of soapy detergent. And that's how we got soapy detergent basically. When we add hydrolysis but with alkali instead of acid. But if we add acid, we will not get the soap. We'll just get carboxylic acid. Okay? So this is very important. Okay, put a star here. And I will stop here. You will notice this polyesters. I'm not going to talk about this in tomorrow as well because it's. I'll talk about it together when we are doing it before exam, UT. It's really easy to pick it up, but I'm not going to waste time on this yet. So that one is more important than this part, so I'm going to emphasize on that first. And tomorrow in lesson time, I will go through together with you practice 33.2. So try to do it at home. Let me give you a hint over here. You can look at a lot of red things. DSE 2012, DSE 2013, DSE 2012, DSE 2013. So soap, soapy, and anything related to the structure has been asked quite a lot. Okay, so try to do. If you cannot do it, it's fine. We'll do it in the lesson time. But if you can do it, that's great. So that's pretty much it for this chapter. Tomorrow I will be giving you the quiz first at the beginning. And then after the quiz, we'll do some examples and exercises of Unit 33. And once we're done with that, I will give you more detailed schedule of the weeks to come, what we're going to do, like how are we going to start Book 3C and the experiments date, hopefully. Okay, so see you tomorrow.